Okay, good morning, good afternoon, good evening to all of you. Welcome to the Access to Space for All Initiative HyperGES second round question and answer webinar. My name is Hazuki Mori, and it is a pleasure to have you all here. So before we begin, I'd like to give you some housekeeping rules. So first, if you have any questions, please use the chat box to ask your questions. Please do not raise your hand. If you have any questions, please write it in the chat box. Second, please answer our questionnaire form that we will be putting in the chat box later on. My colleagues from UNOOSA will be active in the chat, providing you with useful links, and we will also put our questionnaire link there. So please answer our questionnaire before you leave. And third, last but not least, please use the hashtag Access to Space for All and HyperGES to help us promote this webinar. We are active on Twitter, Instagram, Facebook, and LinkedIn at UNOOSA. So this is what today's agenda looks like. First, I will be giving you a short introduction to the Access to Space for All initiative and, of course, the HyperGES program. After that, you will have a short introduction to the European Space Agency, the European Space Research and Technology Center, ESTEC, and, of course, the Large Diameter Centrifuge facility that you will be using for the HyperGES experiments. And after that, we will have a long question and answer session. We have collected some questions through the registration form, but also we are happy to answer any questions that you may have here now. Any technical, administrative, anything related to HyperGES, we are here to answer them for you. So please make sure to write it in the chat box. Okay, so without further ado, I'd like to move on to the short intro of the Access to Space for All initiative. I'm not aware of how many people have been coming to our webinars and know about the initiative, so I'll just be giving you an overview of the initiative. So the Access to Space for All is a joint initiative of UNOOSA and the many different space agencies, research institutions, and universities and industry that you see there. And we offer access to space especially through research facilities and infrastructure, and we also provide information. And the aim is to develop technical know-how, engineering processes, and infrastructure in the different areas of hypergravity and microgravity, satellite development, and space exploration. And we also want to promote the international cooperation in the peaceful uses of outer space. And partnership is a distinctive feature of the initiative. And this initiative is only possible thanks to different partnerships with the various public and private actors who are contributing to the initiative through providing us with access to many different things. So our initiative is actually work in progress, and we are working to expand our support. On the left-hand side, you can see the different three components that are forming the initiative. The hands-on component that you see on top are the actual hands-on research opportunities. Below that, you will see the tools component, which is there to introduce how to use tools such as software, open platforms, and systems that are developed around the world to efficiently and effectively utilize these for the hands-on opportunities. And the education component provides the theoretical foundation to participate in the hands-on component and use the tools under the tool component. And these components are structured to serve three different tracks with three different goals, as you can see on the right-hand side. So the hypergravity and microgravity track aims at building capacity for running experiments on Earth and, of course, on orbit. The satellite development track aims at building capacity that enables the development, deployment, and operation of satellites. And the space exploration track covers different aspects related to space exploration. In this page, you can see the 9 hands-on opportunities we currently have. And as you can see, they are divided into the different tracks. The hypergravity and microgravity track has 5 opportunities. On the left-hand side, you can see our on-ground opportunities. One is called Drop Test, using the Bremen Drop Tower in Germany, which is a collaboration with DLR and ZARM. The second one you see there is, of course, HyperGES, that I will be explaining a bit more in detail, which is utilizing the Large Diameter Centrifuge facility at the European Space Agency. In the middle, you will see a red donut, which is a gap that we would like to fill soon, which is suborbital and parabolic flights. And on the right-hand side, you see our 3 on-orbit opportunities. One is utilizing the Bartholomew platform of the ISS with Airbus. Another one is utilizing the Chinese space station with CMSA. And another one is utilizing the Dream Chaser vehicle of Sierra Space. Below, you see the satellite development track. We have 3 opportunities there. One is PHI, the Payload Hosting Initiative that we just opened with the Mohammed bin Rashid Space Center of UAE. We also have another one called KiboCube, utilizing the Kibo module of the International Space Station with JAXA. And we have another opportunity utilizing the Vega C launcher with Avio. And last but not least, for the space exploration track, we have one opportunity with the Keldysh Institute for the provision of telescopes called ISONScope. And currently, we have 2 opportunities open. You are here for one of them, which is HyperGES, and the other one is PHI, and they are both open during this year. So HyperGES, the deadline is on the end of this month, and PHI will be on the 17th of April. So if you're interested in PHI as well, please make sure to check out the website. And this year, we will be trying to open more opportunities as well, so please keep checking our initiative webpage for this. So going more into the details of HyperGES. So I believe all of you are interested in HyperGES and you're here, so I think you already know this, but just to elaborate again, HyperGES is a cooperation program between UNOOSA and the European Space Agency, which started from 2019. And it aims to provide opportunities for scientists and researchers with a team of students from member states of the UN, and with particular attention to developing countries, with opportunities to conduct their own hypergravity experiments at the Large Diameter Centrifuge facility located at ESTEC in the Netherlands. So why HyperGES? Why is it so special? Well, experiments in hypergravity environments can be used to advance research in different scientific fields such as biology, medicine, material science, fluid dynamics. The list is really a very long one, and it represents an achievable entry point to acquire new knowledge and technology. Second, the LDS facility is a unique facility that accommodates 80 kilo of payload. It allows experiments in gravity conditions that range from 1G to 20G and is flexible in terms of experiment scenarios, duration, and possible equipment to use. So you can do a lot of different things using the LDC facility. And last but not least, through the HyperGES program, international air tickets will be funded by UNOOSA, and there will be a lot of technical support and local accommodation, which will be provided by ESA. So all the teams have to do is provide us with, develop their experiments and come to ESTEC. I'd also like to mention that HyperGES contributes to the SDGs by fostering innovation and supporting education and training on skill sets for developing cutting-edge technology. So we focus on SDG number 4, which is quality education, number 8, decent work and economic growth, and number 9, industry, innovation, and infrastructure. Oh, okay. So with that, I am going to conclude my brief overview of HyperGES. We have more details on our website as well, so please take a look. But now I'd like to give the floor to my colleague at the European Space Agency, Jack, who will be giving us more detailed information about ESA, ESTEC, and the LDC facility. So I would like to hand the floor over to you, Jack.
Good. Can you hear me?
Yeah, we see you and we see the presentation as well.
Okay, thank you very much. Thank you for the introduction for this webinar on the LDC, the Large Diameter Centrifuge, in framework of the UNOOSA HyperGES, UNOOSA ESA HyperGES program. My name is Jacques Verloon. I work at the European Space Agency Technology Center, ESA ESTEC in Noordwijk, the Netherlands, and I'm also affiliated to the Free University Amsterdam, also in the Netherlands. On ESA, the European Space Agency, a short history of that. ESA started off in 1975 by signing the ESA Convention at that time with 10 member states. But now, quite some years later, we have, in 2020 at least, we had 22 member states, and you see the member states, spread over Europe. It's a real collaboration between the various countries within Europe. So you also see that various parts of ESA are located in the different countries. Headquarters of ESA is in Paris, in France. You have facilities in Rome, in Noordwijk, ESTEC, in Darmstadt, in Cologne for the astronaut center. ESAC in Madrid, Oxfordshire in the UK, Redu in Belgium, and Kourou is the launch site in French Guinea. As mentioned, the LDC, the Large Diameter Centrifuge, is located in ESA ESTEC in Noordwijk, and you see the facility here. This is the whole ESA ESTEC site, really on the edge of the country. You see the North Sea here on the top, and vaguely. But the LDC is located in this small dome, more or less in the center of ESTEC. Here you see the dome again. People involved in this TechMMG list lab at ESA ESTEC is Robert Linder. He's the manager of the TechMMG section. Francois Goubert, Alan Dawson, and myself are doing various tasks to have the lab running and the centrifuge running. This is the whole facility where, of course, you have the centrifuge part here, but you have preparation labs, life sciences lab, clean room facilities, small workbench. I get some more images of that later, and you also can look into that later on when you can download this presentation from the UNOOSA website. The main lab, where you have general facilities for biology, so flow benches for sterile working, incubators, freezers, coolers, lab spaces. You have the support lab where you have fume hoods, chemicals, milieu and deionized water, autoclaves, glassware, -80 freezers, and so on. Meeting room to prepare and discuss the experiments. We have a wet lab where we have shakers, incubators, small lab centrifuges, HPLC or LCMS systems. A small workshop if you have to do very little adaptations to your hardware. Of course, we have the LDC control room where you see the LDC at the back here. Here you see the two systems to either control the LDC or the system where the science or user group sits and can monitor and or control their experiment while running. And there's a preparation lab for the LDC before going into the actual facility. So why using centrifuges? If you've seen also in previous slides presented that the focus in space research lies mainly, of course, in the space part. So in our case, the microgravity part, orbiting space flight conditions. But if you're interested in gravity, you have the microgravity here, but I mean, you have this full range of gravity values you can explore. So if you're interested in gravity as such, I think you should both use hypergravity, so anything above 1G, as well as hypogravity, anything below 1G. Of course, the below 1G has, another impact because you need to launch and you have to get into either for long duration experiment. I mean, you have to be in orbital flight and being either at microgravity conditions or use an in-flight centrifuge for partial G conditions, or even go to the moon or Mars to do the actual experiment at the constant partial G level. But for high Gs, you can relatively easy do that on ground, and you can explore, your system and how that responds to high G levels. For the LDC, there are, let's say, two paradigms. You can even use the centrifuge in light of microgravity research. So in the previous slide, I mentioned that you can do hypergravity, just regular hypergravity studies, but you can also use a centrifuge to do microgravity related studies. Sounds a bit strange, but one of the paradigm is to use the gravity continuum paradigm, where you do the experiment at high G, so from 1G to XG, whatever the X is for your system, and you do all these experiments, and based on the results of that experiment, you might be able to extrapolate the data you found from your ground-based or hypergravity studies. So you extrapolate the data, so you think you have a good view of what you might expect if you go to a lower G level. Maybe not all the way to microgravity, but at least you have some indication of what might happen. So this is one way of using a centrifuge in light of microgravity studies. The other one is this reduced gravity paradigm. This is a regular microgravity experiment, as we should probably know it. You are on Earth at 1G, then you launch your experiment, and then you are under microgravity conditions. You have a microgravity response, and you have an adaptation time here. What you can also do is to put that same sample into the centrifuge and have a steady state condition after a while, depending on your experiment, and then lower the G level from 3 to 2G or from 3 to 1G. And then again, you have an adaptation here, going to low G, where you have this reduced gravity compared to the starting condition. So the idea here, or the paradigm here, is that the effects you see here, especially at the very beginning, are similar, not the same, but similar as what you can see under real, microgravity launch conditions. So you can use the centrifuge for regular hypergravity studies, for launch simulations. I see another image of that later, and also, to work to explore more, for instance, where you have your parabolic flight experiments, that you can look into the various aspects of your parabolic flight. The main properties of the centrifuge: it's an 8-meter diameter system. We have 4 arms. We have 7 gondolas, well, 6 gondolas which are really, let's say, swinging on the end, and 1 gondola in the center, which we use for rotational controls if needed. 80 kilograms per gondola you can use. We can go up to 20G for 6 gondolas, and the motor is 22 kilowatt. What do we provide for you within each gondola? We have temperature sensors, we have analog and digital videos, serial connections, Ethernet channels, USB connections, of course power supply. We have fixation points if needed. We have gas and liquid supply to your experiment while running. So each gondola has these facilities, so you can make use of that for whatever your experiment is. This is a very full and complicated slide. I'm not going to explain this again. You can download the PDF from this presentation and have a closer look into this. Basically, what you see is the computers we have on the rotating part of the centrifuge of the LDC, and the computers we have on the static part of the LDC. The connections we have to the control panels and the lab rooms, and this is you get an idea of how the connections is and what you might be able to do to perform your experiment. For data communications, you can have direct link to your experiment, while running at the higher G levels. So be sure to use we use remote PC as one of the things in Win 10 or Windows 11 nowadays. And non-Windows systems, be sure to have administrator rights if you want to do your own, use your own systems. We can also use TeamViewer, and this is experiment dedicated hardware if you use your own system, but we have to configure it accordingly. It's a swing out system, the LDC, which means that the gravity vector is always perpendicular to the floor of the gondola. So if you run at the higher G levels, the gondola will be, let's say, more horizontal, but again, the G vector will always be perpendicular to the floor. The gondolas are pretty, pretty spacious, but be sure, I mean, the clearance is in the user manual as well, but be sure not to configure the hardware, your own hardware, such that it just not fit through the door, and especially because of the hinges or the round edges you have in the door. So be aware of that. But if you are selected for experiment, we surely iterate a couple of times to make sure that that the experiment will work. We also can provide you with gas and liquid containers in the center. So if you need a specific gas for your experiment, it is possible. What I mentioned earlier, these are some profiles. Here we have a launch profile of a Soyuz rocket, where you go from 1G to about 3.7G and then go back again, the second stage and the third stage of your launch. You can follow such a profile in the LDC. This is, let's say, the quickest spin-up you can generate, going from 1G to 20G. It takes about 60 seconds to go to full speed. Full speed is about 100 kilometers an hour in the system. If you manufacture your own hardware, be sure that, let's say, the essential part, so that your sample itself is as much as possible in the center of the gondola, because there you have the most uniform or the best gravity conditions or hypergravity conditions. The soon, as you deviate from the center, either in XY direction or Z direction, you get a deviation from the, let's say, the maximum or best G level you can generate in the LDC. So try to be as close as possible to the center and to the floor of the gondola. This deviation can be, well, it's not much, it's an 8-meter diameter system, but you still can have this gradient over the height or over the XY position in the gondola. So you want to reduce that as much as possible. Some LDC experiment capacity examples. We can have, multiple G levels in the same run. So you can have one experiment running at, for instance, 10G, and the second experiment running at the same time at 5G, or any G level, in between the two. The maximum difference is about factor 2 between these two G levels. If needed, we can have different temperatures in the gondola, especially for life science experiments. They tend to be at 37 degrees, for instance, or another ambient temperature, which want you to keep constant. We can do that with incubators in there. Well, incubators capable of withstanding high G levels. Sometimes the instruments of your experiment, are larger than will fit in one gondola, so then you can place part of your experiment in an adjacent gondola, connected with various cables and so on. So here's where the sample is, and this is the auxiliary or supporting equipment for your experiment. We can have the gondolas sitting in the preparation lab, so you can do the preparation in the lab, before we transport the gondola onto the LDC and do your experiment. And be sure, especially if you're, if you are in life sciences, to have as much samples needed for your experiment. So some example experiment configurations. Here we have an impact experiment where we have some regolith material and a projectile which was shot onto this regolith at high G levels to explore the impact on meteorites and so on. And crab neurovestibular experiment. It's a bit small here, but here's a crab sitting there, and we have the electrodes connected to his vestibular system. Mass and heat transfer experiment, where we had also a lot of cooling capacity here on the side with this heating structure inside the gondola. Work on planetary and glacier research, where we have a model glacier material here, so we can explore what a glacier might do at different celestial bodies. So how would a glacier progress in the different G levels on a different planet? The bubble generation experiment, I think this experiment we needed 5 cameras to really monitor the experiment while running, so that was pretty complicated. Here we have a zebrafish in the LDC, but the same zebrafish we also have in the microgravity simulation on the random positioning machine, working here in clinostat mode. And for life sciences, mostly for life sciences, we also have a couple of microscopes you can use in the centrifuge while at different G levels. This is the EVOS 7000 fluorescent microscope, and we have a light sheet microscope. So this is really to look into 3D structures. So the HyperGES proposal, what should be clearly addressed in that proposal? You should clearly address why to use the LDC. So use the LDC for regular hypergravity studies, for launch simulations, low gravity extrapolations, or microgravity simulations like the reduced gravity paradigm. You should identify that and why. science and application background and rationale, preliminary data from your own or from literature references is needed to put your proposed science into perspective. Also, how to use the LDC, identify what the parameters are to measure and how, either online or post-exposure. Expected outcome of your experiment is very important. Show preliminary hardware configuration. It doesn't have to be detailed, especially not in the proposal stage, but we do have to understand what you want to do and how you want to do it. Think about the schedule and logistics, very important. Also the logistics from your home country to the Netherlands, to ESTEC, and the way back, by the way. So how to handle that. How to communicate your results is also important. So you have to report them, but also we would like to see you to have them published in peer-reviewed papers, in conferences, presentations, or local and social media is also important. So before uploading your proposal, recheck all the parts of your proposal that they are completed. When proposals are not completed, we cannot take them into account. So this also, again, a very full slide, but here you see the, let's say, he made a separation of the sort of experiments we did in the LDC. So these are some very general papers on that. These are experiments done in fluid physics, in cell biology, plasma physics, plant biology, animal physiology, geology, technology, and material sciences. So here you see the peer-reviewed papers that have been published on these subjects. So if you go to them and you have a hyperlink to the various papers available on the web. So if there are any questions or remarks, we can do that after, during this webinar, but otherwise, drop me an email and I can provide you some information. So thank you very much.
Thank you so much, Jack, for this really detailed presentation about ESA, ESTEC, the LDC facility, the many different things you can do there, and of course, the advice at the end. I think that was very helpful for everyone who is applying. Okay, now with this, I'd like to move on to the actual Q&A part of our webinar. So I don't see any questions. I actually see one question in the chat, but if you have more, please keep sending them in. We will start with the ones that we received during the registration process. So we'll have a little presentation again, but then after that, we'll dive into the questions that'll be coming in from you, from the crowd. So please make sure to write it in the chat. Okay, I'd like to invite my colleague, Jorge Del Rio Vera, who will be organizing this part of the session. So Jorge, if you're here, you can start with the Q&A part.
Thank you very much, Hazuki. Thank you all, Jack, for your presentation. It was very, very insightful. So let me share my screen because we have been collecting some of the questions in the registration form. So we have grouped the questions and hope we can answer those here. But if you have questions, don't hesitate to write them in the chat. I've seen that some of you have already started doing that, which is very good. So I hope you can see my screen. Can you confirm, Hazuki?
Yeah.
You can see my screen. Perfect. Thank you. So probably the first question and the first question that we have seen is how do you apply to the second round? Well, let me show you how to navigate the UNOOSA website to do that. It's very simple. So if you go to the UNOOSA webpage, unoosa.org, there you find the main page of our office, but you have a section on access to space for all. HyperGES is under access to space for all. So basically, if you want to read more, you are directly sent to the access to space for all webpage. Also in our work, you will find access to space for all there. So whichever way is more convenient for you. When you are in the access to space for all webpage, scrolling a little bit down, you have opportunities, and HyperGES is under the hypergravity and microgravity track. So there you find all the information that is related to this track. HyperGES is a hands-on opportunity under the hands-on component. Anyway, you have the news here. So It's talking about the round being open for application. Check out the new round. So you don't need to go farther in the website. You can actually click from here. But if you want to have a closer look to the hands-on component, there you have the different opportunities. You have HyperGES, of course, and you have very interesting information about who has been awarded HyperGES. So HyperGES awardees, in case you want to see what has been done, even though this team has not completed their experiment yet due to COVID, but you can read about what they were proposing, and you have plenty of information in here, including an interview that we conducted last year with the team. So that information is there, and it can be very helpful. You want to apply, so you go to rounds, and in rounds you have all the documentation that is needed. Even you have webinars that we have been conducted on this round, so you can find even additional information. There you have the announcement opportunity and the application template together with reference material that Jack was mentioning in his presentation, like the user manual of the centrifuge and technical constraints. In addition, also there you have example of past experiments. I mean, this is redirecting to an ESA website and explaining you what has been done in the past. So if you want to collect ideas for your experiment, if you still don't have clearly in mind what you want to do, I mean, those are great resources that are there. And the documents that you need for applying is the application template, the application form template, and the announcement opportunity. The announcement opportunity lays out which are the requirements and how we are going to select, and also the timeline for the round, while the application form is what you have to submit, and all that is clearly explained in the announcement opportunity. So sorry, let me minimize this and go back to the slides. So there you have basically the way on how to get to that web page and to find the documents that you need. We will put this presentation online, so you will have also this link. If you want to go directly there, you can utilize the presentation that will be posted soon. Then the other question, I was also already answering that question, is which materials can be useful in building the application? Well, I was mentioning some of those. You have a lot of webinars that we have conducted and have been general webinars. So let me go back to the hypergravity and microgravity track. There you have the education component. In the education component, we have common education resources, like tips on how to raise awareness about your project, space law and regulations, which are not very much applicable to this, experience from past winners, and also artificial intelligence in case you want to integrate some artificial intelligence experiment. So you have that information that is general information. On hypergravity and microgravity specifically, we conducted a series of webinars last year, and there you have a complete overview of the hypergravity and microgravity field, and it's grouped per topic. We had also presentations from our partners, including ESA. Jack was presented several occasions, and there is additional resources, although this is more applicable for clinostats, but still you can actually gather some ideas also for the teacher's guide to plan experiments in microgravity. So all those resources are under the education component of the hypergravity and microgravity track. And I was mentioning before the links to previous experiments that have been run in the centrifuge. So you have all those resources in there. So just go to the website and actually check those resources out. You will have, again, you will have the links in there. So you will find them very easily. Deadline for applications. So we are conducting this webinar on the 3rd of February. You don't have too much time left, but you still have time if you want to put an application together. The application form, and you will see the form in a minute, is not that complicated. So you still would have time to submit an application, but the deadline is the end of this month. This is how the program schedule looks like. We also got the question on what is the program schedule. The application has been open for quite a while, and I assume that some of you are interested already in applying and are already working in the application form. Then we will take a couple of months for selection. I mean, the time allows us for evaluating several proposals, and we are accommodating for a decent number of proposals to do the selection. Then when the selection is completed, the awardee will be notified, and it will start the preparation time, the preparation of the experiment. Then running the experiment will take 2 weeks. So the experiment will have to be integrated, and then the experiment will have to be run in the centrifuge. I mean, there are experiments that have different durations. So if you have a shorter experiment, I think that's also feasible. You can have experiments that are shorter. Then you will have to report about which have been your results. I mean, we are talking about an opportunity that is very much science oriented or engineering oriented also. So we would like to hear from you we will see in your application what has been your hypothesis. Jack was mentioning the different points, which are the things that you expect to measure. And then you will be running the experiment, you will be collecting data, and we will be waiting for a report from you on the experiment that you have been running 2 months after you have run the experiment. So we'll also see and we'll be able to share the information. Of course, if you have any concerns, I mean, if you have been collecting data in your experiment and you are expecting to do a peer review publication, and that normally takes time, we will hold the report as much time as you tell us, and we will not put it in the website until you tell us, but we will need to see the report. Then about the eligibility criteria, you have that information in the announcement opportunity. And these are screenshots of the announcement opportunity. I will show you exactly where in the announcement opportunity that information is. So again, you come to the hypergravity and microgravity track. You go to HyperGES, and you go to the round. The announcement opportunity document is here, and you have information about that in here. About what is the team that we are expecting to see. So you see 1 academic supervisor and 3 team members. So only up to 4 team members, including the supervisor, will be funded. So that's the total. It doesn't mean that the team can have more members. That's possible, but the funding that is available for this opportunity is only covering up to 4 team members. Just to make it clear. Then you see there is academic supervisor, and we are talking about students. So if you want to know more about what, so you will have that information in the eligibility criteria. So it's section number 12 of the announcement opportunity. Please read the announcement opportunity in full when you are applying. And there you see it's open to entities that are located in member states of the United Nations. And we will be giving special attention to developing countries, but it's not restricted to only developing countries. Just to make that very clear. And we are talking about 1 academic supervisor and then several bachelor, master, or PhD students. That's the team. And that's a team that would be eligible coming from a university, educational institution that is giving either bachelor, master, or PhDs. I think that's covering that question. I don't know if Jack, because I'm talking very fast. I don't know if you would like to add. Please interrupt me anytime.
No, I think it's fine. Thank you.
Thank you. You see here that we will be asking a letter of endorsement of the institution. That's something that you will have to attach to your application form. That's why you have to read this documentation very, very much in detail and pay attention to it. It's a very short document. Selection criteria. Jack was talking about the science behind, and that's very much important for us. I mean, we have to see that you are thinking in what is the role that hypergravity is playing in your experiment and which type of science and conclusions you would like to extract. And that is reflected in the main criteria that we have. So scientific and technical value, relevance of hypergravity, relevance on the LDC utilization. So all that it's covered in here. There are a couple of things that are important in addition for us. So the first thing is about the financial resources. In this opportunity, we are not covering the development of the experiment because, I mean, there could be 1,000 experiments and that's part of your application and your engineering process. So total freedom there, but we will not be covering the cost related to the experiment. What we will be covering is travel, and we will be covering also the utilization. Well, the European Space Agency will be covering the utilization of the LDC, the Large Diameter Centrifuge. So you will have to find financial resources to support your development and the transportation and shipping of the experiment. As Jack was mentioning, you have to consider that you have to ship the experiments to the Netherlands and back to your country of origin. In addition to that, it's a capacity building opportunity under Access to Space for All. So we are very much concerned about building capacity in institutions of member states. So we are trying to understand what you are doing in that regards by the communication and dissemination plan, how you are going to disseminate and communicate your results. Maybe you are, and for instance, the previous awardee was going to schools to talk about the experiment that they would be running in ESTEC. But you can have many ideas on how to communicate and disseminate the information that you will be acquiring in the experiment or even the process of running your experiment. And then inclusiveness is very important. In the space industry, all over around the world, there is a small percentage of women compared to the total population of women in the planet. We are talking about a ratio of around 20 to 30% of women with regards to 80 to 70% of men. So we like to see inclusion. I mean, it's not only about gender inclusivity. I mean, also inclusivity of persons with disabilities, of persons with different sexual orientations. That's to be included in your application. If you have a more diverse and inclusive team, that will be judged positively. And if you are equal with another team that has a very good science behind, and you have a very good science behind, we will be valuing the inclusiveness, basically to disentangle the draw between the applications. And also the link of the project to the Sustainable Development Goals. I'm sure that you know about the Sustainable Development Goals. Let me very quickly show you information about that. Probably you can utilize any search engine for that. Basically, sustainable. And even in the UNOOSA website, you have information about that. UNOOSA, because we have a project that is called Space for SDGs. There you can see the 17 Sustainable Development Goals. You can find information about the agenda, the 2030 Agenda for Sustainable Development. If you are opening that document or that website, you will find information about the agenda itself. And there in the agenda, you will find the 17 Sustainable Development Goals. If I scroll properly, yeah, there you have the 17 Sustainable Development Goals, and each of the goals have a number of targets below. So please be sure when you are making your application not to stay at the goal level. I mean, of course, you can stay at the goal level, but you can actually go below and go to the target level. I mean, that will give us more information that you have understood better the Sustainable Development Goals and you have been able to make a better connection. Of course, you can link to the upper level, which are the goals, but linking at the level of target is actually better. So those are the things that we will be looking at. Again, I mean, we have been talking about inclusiveness. We have been talking about budget. We have been talking about the Sustainable Development Goals and Communication and Dissemination Plan. The most important for this is science. So there will be a technical assessment of the science that you want to do. If the science doesn't work or your experiment is not related to hypergravity, it will not fly. Well, it will not fly. It will not be spin. But provided that those are met, we will also utilize the other criteria to basically compare applications that have similar quality. So just keep that in mind. Example of links with the Sustainable Development Goals. I mean, we have many. And again, in the UNOOSA website, you can actually find many. For instance, there have been a team in Bolivia that were running experiments, not in hypergravity, but in microgravity, about the behavior of a small material in microgravity conditions. And that experiment can be replicated to understand the behavior of that smart material in hypergravity conditions. So you get basically the full range of gravity up to the limits of the LDC. So you can characterize the behavior of the material with gravity, and that would be feasible. I mean, the very same team was the team that was developing a low-cost ventilator to fight COVID in Bolivia. So actually there is a link with the skills that you are actually putting at work in opportunities like this, like HyperGES that we are having together with the European Space Agency. And there are more examples. I mean, there are teams that have been very successful in having gender balance in the team, and they have been very successful also in showcasing that. There are many examples. I mean, just have a look at the UNOOSA website, you will find more examples there. So the support is, again, you find the information about the support that is provided in this opportunity. You get international air tickets, you got the utilization of the LDC, and ESA also will be supported the local accommodation. So basically what you need to do is to develop your experiment, and other costs that are related to the experiment, including the shipment of the experiment to the LDC, to Noordwijk in the Netherlands. So that information you find in the announcement opportunity. How do you submit the application? Again, that information is in the announcement of opportunity in the web page that I was showing before. You take the application form, the letter of endorsement, and you submit those to the email address that you have there in the screen. That email address is in the announcement opportunity. So this information is just basically a screenshot of the announcement opportunity. I mean, just be careful with the amount of the size of your documents, because there is a size limit, because of email constraints on our side of up to 10 megabytes. But besides that, no problem. Okay. And those are all the questions that we were collecting through the registration. But I guess that there were some questions in the chat. So I don't know, Jack, if you would like to add anything. If not, I hand over to Hazuki for the rest of the questions.
No, I think you addressed the most important part, and of course you presented a lot of data, so people can also look back at your and my presentation to if they need some more additional information.
Over to you, Hazuki.
Okay, thank you very much, Jorge, for that detailed Q&A part that we collected from the registration form. If you have any other questions, please make sure to write it in the chat. This is the best timing. Both UNOOSA and ESA are here, so we'll be able to answer all your administrative and also your technical questions. So I see one question from Nina, who is asking, can all the 6 gondolas of the LDC facility be used for the experiment? So I'd like to ask that question to Jack. So can we use all 6 of them?
Yeah, thanks, Nina, for the question. Well, actually, you can use all 7 of them if you if you really want to. As you might remember, we also have the central computer, that one, which can be used as rotational control or something also to store instruments. But yes, all 6 computers can be used. They can be monitored. They have power and whatever facilities in there. So we see a lot of, especially if you go for life science experiments, where well, normally you use quite some samples, to increase your statistics. You see that more than 1 gondola is used. If you go for other disciplines, physics related experiments, there are most of the time using one gondola, 1 experiment. So any specific reason you want to use 6 at the time, or?
I see that there is a question from Marianne. Can the team be from different education levels, PhD and masters? So this is about eligibility. Maybe I can give the floor to Jorge.
Again, I mean, all the answers that you are looking for are in the announcement opportunity. So just go to the announcement opportunity. There you find the information. I mean, each team should consist of 1 academic supervisor and several bachelor, master, or PhD students. I mean, there is nothing preventing that a team has the different levels, but the academic supervisor is 1. So the academic supervisor should be involved in the different schemes in order to be sure that is connected to the studies that the person is teaching. But there is no prevention of that in the announcement opportunity. So actually that can happen, and probably that would be even useful for the students that are lower level to be engaged with the students that are at PhD, for instance.
I would like to thank all of you for being here and having interest in HyperGES. As Jorge and as Jack have been mentioning, you still have 1 month, well, roughly a few weeks to put your applications together. And we really, really look forward to receiving your different ideas on experimenting at the Large Diameter Centrifuge facility. So thank you again. Thank you, Jack, for the presentation. Thank you, Jorge, for the Q&A. And thank you all. And we wish you a very good day. And we wish you the best, of course, on the health, but also good luck with your applications. Thank you, everyone. Bye.